Asteroids have always intrigued and terrified humankind, occupying a place in our collective imagination as both cosmic messengers and potential harbingers of doom. Over the years, they have been featured in countless films, books, and scientific studies, often portrayed as objects that threaten to wipe out civilization in a cataclysmic event. While this fear may have seemed like science fiction for much of human history, the reality is that asteroids are a very real threat that scientists are actively monitoring. One such asteroid, known as Apus, has recently become a focal point of scientific research due to its potential to impact Earth in the not-so-distant future. For the first time in history, humanity faces a scenario where a massive asteroid could plunge us into global chaos. While this might sound like the stuff of movies, the science behind Apus's potential impact is grounded in reality, and it's only a matter of time before it crosses Earth's path again. This threat has been known for some time. Apus, officially designated 99942 Apus, was first discovered in 2004, and its size and orbit have made it one of the more closely watched objects in our solar system. At around 370 meters in diameter, Apus is large enough to cause significant damage if it were to collide with Earth. For years, astronomers have monitored the asteroid, analyzing its orbit and calculating the potential risks. Initial concerns about its path led to fears that it could collide with Earth as early as 2029, sparking widespread panic. However, further calculations showed that, while the risk was not zero, it was small enough to reassure the public and allow scientists to focus on other projects. Nevertheless, Apus's trajectory remains unpredictable, and in 2036, it will make another close pass by Earth, presenting the possibility of a more direct threat. While current models suggest that the asteroid will not collide with Earth in the near future, there remains a significant level of uncertainty, and scientists are taking this potential threat seriously. The latest research surrounding Apus, including studies conducted by NASA, has provided new insights into the asteroid's future and its potential impact. These studies have shown that while the asteroid's immediate trajectory may not pose a direct threat, there are still several factors that could change its course. The most pressing concern is that Earth's gravity could alter Apus's orbit during its close approach in 2029. If this happens, the asteroid could be nudged into a new trajectory, one that might bring it closer to Earth in the future, with a potential collision in 2036. If Apus's orbit does indeed shift, scientists would have just under 7 years to come up with a plan to prevent the impact. The possibility of a sudden change in the asteroid's orbit is a major reason why experts like Dan Riskin, a Canadian evolutionary biologist, continue to raise awareness about the dangers of Apus. Riskin's warnings about the asteroid have sparked significant discussions about humanity's preparedness for such a catastrophic event. As an expert in evolutionary biology, Riskin is deeply concerned about the long-term consequences that an impact event would have on human civilization. His research emphasizes the unpredictability of asteroid impacts and the potentially devastating consequences that could arise from one, not only in terms of immediate destruction but also through long-term global climate changes. Riskin has argued that while Earth has been struck by asteroids in the past, the impact of a large asteroid like Apus could trigger an unprecedented global crisis. The consequences of such an impact would go beyond the immediate loss of life. It could fundamentally alter the course of human history. NASA's studies on asteroid defense have also highlighted the critical role that international cooperation and preparedness would play in mitigating the impact of a potential asteroid strike. The space agency has been conducting extensive simulations to understand the potential effects of an asteroid collision with Earth, including hypothetical scenarios where a previously undetected asteroid is on a collision course. These simulations have revealed significant gaps in global preparedness and emphasized the need for countries to come together to address this existential threat. While the asteroid defense community has made significant strides in understanding the risks posed by asteroids like Apus, much more work remains to be done in terms of developing effective strategies for planetary defense. In particular, the question of how to prevent an asteroid impact is one that scientists continue to grapple with. The primary strategy for defending Earth from an asteroid like Apus would involve attempting to alter its orbit by either pushing it off course or deflecting it using various technologies. One possibility is the use of nuclear weapons to detonate near the asteroid, attempting to change its velocity and trajectory. Another approach could involve sending spacecraft to rendezvous with the asteroid, using their gravitational pull to alter its path. However, these methods are still in the experimental stages, and there is no guarantee that any of them would be successful. As Riskin points out, the question of whether humanity can ever truly be prepared for such an event remains unanswered. While the challenge of preventing an asteroid impact is daunting, the real danger lies in the aftermath of such an event. Apus's potential to cause widespread destruction is not limited to the immediate impact zone. If the asteroid were to strike Earth, the resulting explosion would release an immense amount of energy, equivalent to several nuclear bombs going off simultaneously. The impact would create a massive crater, and the shockwave from the explosion would obliterate everything within a large radius. Depending on where the asteroid hits, the consequences could range from devastating regional destruction to catastrophic global effects. If Apus were to strike the ocean, the immediate aftermath would include massive tsunamis that could flood coastal areas and cause untold damage to infrastructure and populations. Furthermore, the environmental effects of an asteroid impact could be just as devastating. In the case of Apus, the impact could throw vast amounts of water vapor, dust, and other particles into the atmosphere, blocking out sunlight and causing a dramatic cooling of the planet's surface. This impact winter scenario could last for months or even years, disrupting the global climate and leading to crop failures and food shortages. In such a scenario, survival would depend on our ability to adapt to the changing environment. New agricultural techniques, such as indoor farming and genetically modified crops, might become necessary to sustain the global population. However, the challenges of feeding billions of people during such a global crisis would be enormous. An impact on land would cause even more immediate destruction, with the explosion releasing an energy equivalent to several nuclear bombs. In a densely populated area, the loss of life would be catastrophic, and entire cities could be wiped off the map. The long-term environmental effects would be felt across the planet, as the shockwaves, fires, and release of toxic gases would severely disrupt ecosystems and human societies. In the worst-case scenario, the impact could cause long-lasting environmental changes, such as shifts in the Earth's climate and a dramatic alteration of ecosystems. These changes could make it difficult for humans and animals to adapt, leading to widespread extinction and a collapse of civilization as we know it. Despite the potential for such catastrophic events, the reality is that humanity is still largely unprepared for an asteroid impact. NASA's latest asteroid defense study has revealed significant gaps in international preparedness, particularly when it comes to coordinating a global response to a potential asteroid strike. While some countries have begun to develop asteroid detection and deflection technologies, many nations lack the resources or political will to address the threat seriously. Additionally, the financial costs of planetary defense efforts are daunting, and there is no clear plan for how such efforts would be funded or coordinated on a global scale. In recent years, NASA has focused on improving its ability to detect and track asteroids, particularly near-Earth objects, NEOs, like Apus. The agency has developed more advanced telescopes and tracking systems to identify potentially hazardous asteroids and predict their trajectories with greater accuracy. However, as the recent simulations have shown, there are still significant gaps in our knowledge of asteroids and their behavior. For example, there are still many asteroids that remain undetected, and new discoveries are being made all the time. As the simulations have also demonstrated, the political and logistical challenges of mounting a coordinated global response to an asteroid threat would be immense. Countries that are currently in conflict or dispute would have to put aside their differences and work together to address the threat, something that may be easier said than done. Despite these challenges, NASA and other space agencies around the world are working tirelessly to develop new technologies and strategies to protect Earth from asteroid impacts. One of the most promising developments in this field is the OSIRIS-Rx mission, which aims to collect samples from Apus and bring them back to Earth for analysis. This mission will provide scientists with valuable insights into the composition, density, and other properties of the asteroid, which could help inform future efforts to prevent an impact. The information gathered by OSIRIS-Rx could also help researchers develop better methods for deflecting asteroids and predicting their behavior. While much progress has been made, the reality remains that humanity is still far from fully prepared to deal with the threat of asteroid impacts. As Riskin and other experts have pointed out, we must act quickly to develop and implement effective asteroid defense strategies, as the clock is ticking. The risk posed by Apus and other asteroids is not something we can afford to ignore. While the chances of an asteroid striking Earth in the near future may be low, the potential consequences of such an event are so severe that we must take every possible precaution to protect our planet and our way of life. In the coming years, we can expect to see increased efforts to detect and track asteroids, as well as continued research into ways to deflect them. We may also see international collaborations and treaties aimed at improving global preparedness for asteroid impacts. The threat posed by asteroids like Apus is real, and while it may seem like science fiction, the stakes are incredibly high. The time to prepare for an asteroid impact is now. We can't afford to wait until it's too late. By working together, pooling our resources, and developing the necessary technologies, we can increase our chances of surviving an asteroid impact and ensuring the survival of human civilization. The future of our planet may depend on it.